Okay, let's talk about the Doppler effect. We've all heard of the Doppler effect. You're sitting at a train crossing and the train's coming towards you, and you can hear the whistle of the train. And then, right as the train passes you, it sounds like the pitch drops suddenly. Or if an ambulance is passing you, it's coming up from behind, the pitch is high, and then after it passes you, the pitch suddenly drops and becomes a lower note. That's the Doppler effect. And what it's caused by is here we have, say, some sound source emitting waves, sound waves that are traveling spherically out from it. If that source is moving, say, toward me, then it's emitting sound waves that travel out in spheres, but it's catching up with its own sound waves because it's moving, say, in this case, to the right. So the woman standing here is going to hear these sound waves bunched up. That means the wavelength is decreasing, which means the frequency is increasing because the wave speed is constant, speed of sound in air here. So she'll hear a higher pitch. The guy here standing behind the car, these sound waves are coming at him and they're being more spread out than they should be. Instead of being this distance apart, they're a further distance apart because the car has moved a little from creating this wave, it moved a little before it created this wave. So the distance between those waves is bigger than it would be if the car were sitting still. So this guy sees lower wavelengths or longer wavelengths, which would mean lower frequency, lower pitch. Similarly, if the source were sitting still and you were moving in relation to the source, moving toward the source or away from it, you would hear different pitches. If you're moving toward the source, the pitch would go up. If you're moving away, the pitch would go down. Okay, and you can read all that. Here's our formula we're going to use. This is the most generalized formula. This works in all cases, whether you have a moving source or a moving listener. So here, V is the speed of sound in air for something stationary, which will usually take to be about 340 meters per second. And that will be given to us. This is the actual pitch that the source is making, Fs. This is the pitch that the listener hears. Okay, so we've got all these different scenarios here. The observer, the listener, might be moving, or the source might be moving. And notice how we've got this plus minus on top and minus plus on top bottom. The reason for that is because if you divide by a bigger number, a fraction gets smaller. So we got to be careful. If something changes in the bottom, we use the opposite sign of what we would expect. Because if our source is more moving toward us, we would want the entire fraction to get bigger. That would give us a bigger frequency, a higher pitch. Well, in order to make the entire fraction get bigger, the bottom has to get smaller, so we would use a minus there. Okay, so here are all, like this table tells you everything, when to use plus, when to use minus. But here's the key, and we'll do this in an actual example with drawings. Here's my shortcut for you. To figure out whether you want a plus or a minus on top or bottom, you draw a picture with your listener and your source. You draw arrows for anybody that's moving in the direction that they're moving. You draw a big arrow that starts at the listener and moves toward the source. So that this arrow goes from the listener toward the source. Anybody that's moving in that same direction gets a plus. Anybody moving in the opposite direction gets a minus. So when using this formula, the question is whether to use the plus or minus. The key is draw a vector, an arrow from listener to source. If the observer is moving in that direction, moving toward the source, we'd use the plus here. If the source is moving in the same direction as that arrow we drew, so that would mean away from the source, we would use the plus. If the listener is moving away from the source, opposite of that arrow we drew, we would use a minus. If the source is moving toward the listener, opposite of that arrow we drew, we would use the minus. Okay, and this will make more sense when we do some actual examples with pictures that I can show you.